need to use the Lagrange's mean value theorem to show that this left hand side is less than equal to sine inverse x less than equal to this right hand side, where x is greater than equal to 1/2 and strictly less than 1. So here we consider two cases. When x is equal to 1/2, because here it is given that x is greater than equal to 1/2, and the second case when x is strictly greater than 1/2 and strictly less than 1. Right? So let's start with the solution. So for this inequality where x is greater than equal to 1/2 and less than 1, first case we have taken that when x equal to 1/2, right? So let's check this expression first. Just put x equal to 1/2 over here. So this is pi by 6 plus 2 into 1 by 2 minus 1 divided by square root 3. So that gives pi by 6 plus, so this becomes 1 minus 1, that is 0, divided by square root 3. So this is 0. So we are getting pi by 6. Then is sine inverse x. So we write sine inverse for x equal to 1/2. We are getting this value to be equal to, yes, this is pi by 6. And then the third one, pi by 6 plus 2 into 1/2 minus 1 divided by 2 square root of 1 minus x squared. So this is equal to pi by 6 plus this again becomes 0. So we are getting again pi by 6. So all these values are equal. So when x equal to 1/2, these all are equal. Then is the second case when x is strictly greater than 1/2 and less than 1. So for that, let's consider the interval from 1/2 to x, where x is strictly less than 1. And let's take the function to be sine inverse x. And now checking the conditions for the Lagrange's mean value theorem. For that, first let's calculate the derivative of fx. So the derivative of sine inverse x is 1 divided by square root of 1 minus x squared. And this derivative exists for all x belonging to the open interval 1/2 and x, where x is strictly less than 1. Okay, the first condition for the Lagrange's mean value theorem, that the function is continuous or not. So yes, fx equal to sine inverse x is continuous in the closed interval 1/2 to x, where x is strictly less than 1. Sine inverse x is continuous in its domain -1 to 1. And if it is continuous in its domain -1 to 1, so is also continuous in this closed interval 1/2 to x, where x is strictly less than 1, yes? Second condition, the function sine inverse x is also derivable in the open interval 1/2 to x, where x is strictly less than 1. So now we can apply the Lagrange's mean value theorem. So therefore, by Lagrange's mean value theorem, there exists at least one c that belongs to this open interval such that f dash c is equal to f of b. What is b? It is for this interval. This is your b and this is your a. So f of b, that is f of x, minus f of a, that is f of 1/2, divided by x minus 1/2. So now what is f dash c? What is f dash x? It is 1 divided by square root of 1 minus x squared. So f dash c becomes 1 divided by square root of 1 minus c squared. That is equal to, the function is sine inverse x minus f of 1/2. Just put here x equal to 1/2. We get sine inverse 1 by 2 to be pi by 6, divided by x minus 1/2. So this is equal to sine inverse x minus pi by 6 divided by 2x minus 1 divided by 2. Very fine. Okay. So this is 1 divided by square root of 1 minus c square, and let's mark this as 1. Now here c is strictly less than 1 and strictly greater than 1/2 for this interval. So now we need to make this expression from this and get the desired result. So let's take square all over. We get 1 divided by 4, strictly less than c square less than x square. And when taking the negative sign all over, the sign changes, and then adding 1. So we are getting 1 minus c square, but we need to get 1 divided by square root of 1 minus c square. So what is this? This is 3 divided by 4. Taking the reciprocal now, so this is 4 divided by 3, 1 divided by 1 minus c square, and 1 divided by 1 minus x square. And when taking the reciprocal, again the sign changes. Now taking the square root all over, we get 2 divided by square root 3. And here we get 1 divided by square root of 1 minus c square, and then this is 1 divided by square root of 1 minus x square. Just replace this 1 divided by square root of 1 minus c square with this expression. Let's multiply with 2x minus 1 divided by 2 all over. We get 2 divided by square root 3 into 2x minus 1 divided by 2 less than sine inverse x minus pi by 6 and less than 1 divided by square root of 1 minus x square into 2x minus 1 divided by 2. So these two cancel out and we get 2x minus 1 divided by square root 3 here. And here 2x minus 1 divided by 2 into square root of 1 minus x squared. Now adding this pi by 6 all over, we get pi by 6 plus 2x minus 1 divided by square root 3 strictly less than sine inverse x and less than 2x minus 1 divided by 2 into square root of 1 minus x squared plus pi by 6. So this is the required result which we needed to prove, and where x is greater than equal to 1/2 and strictly less than 1. So for x equal to 1/2, all these expressions are equal. For x greater than 1/2 less than 1, we are getting this required inequality, right? So hence the result. Thank you.